Good morning, students. I'm Dr. Somyajit Ghosh. Today, I'm going to present the corrosion. In this presentation, we'll discuss about what is corrosion, how many different types of corrosions are there, what are the factors responsible for corrosion, and particularly we'll emphasize on dry corrosion and wet corrosion. So what is a corrosion? Particularly if any metal is exposed to iron or air, slowly some type of reaction products will be formed on the surface of that metal, and that is how we refer it as a corrosion. For example, if we expose iron to air and water, rust forms in a short time, showing the familiar color of reddish brown iron oxide. So depending on the environment, the rust may develop in minutes. We can see here that reddish brown precipitate, which is nothing but iron oxide. So we can call it as a rust. So this is a perfect example of corrosion. So usually corrosion refers that the deterioration of a material because of reaction with the environment. If we keep some pristine metal or pristine material and over the time it exposed with the air and water, some reaction happens, and that is why that pristine nature usually goes down. Instead, some oxide, some reaction product will be deposited. So basically, corrosion involves the interaction or reaction between a metal or alloy and its environment. It is affected by the properties of both the metal or alloy and the environment. So what are the environmental factors which influence the corrosion? It can be pH, acidity, temperature, and the concentration. So these are the factors which are responsible for corrosion. So the corrosion literally consumes the material, reducing the load carrying capability. So when, as I told, that pristine metal, when over the time it forms a reaction product. So corrosion product, when it will be deposited on the surface of the metal or alloy, it will reduce the load bearing capacity. Corrosion is often a major part of maintenance cost, and corrosion prevention is vital in many designs, selection of engineering materials. So that is why it is very essential to prevent the corrosion. We have to employ the several strategy to prevent the corrosion. Corrosion in qualitative terms can be expressed as the material is immune, resistant, susceptible, or very susceptible to corrosion. So if the material is immune, that means we can say that it will not readily undergo the corrosion if it is exposed to the environment, or we can call it as a resistant. But if any particular metal is readily undergoes corrosion, we can call it as it is very susceptible to the corrosion. So what are the types of corrosion? Corrosion is commonly classified based on the appearance of the corroded material. There can be different types of corrosion: uniform or general corrosion, localized corrosion. Localized corrosion is crevice or pitting corrosion, intergranular corrosion, environmental cracking, erosion corrosion, fretting corrosion, de-alloying, etc. Now we are going to talk about one by one that different types of corrosion. First is uniform corrosion. Corrosion that is distributed more or less uniformly over a surface. So the name itself suggests that the corrosion products are deposited uniformly over the surface of the metal. For example, if iron metal is exposed, we will see that corrosion product or iron oxide is uniformly deposited. So that is why it is an example of uniform corrosion. Another is localized corrosion, corrosion that is confined to small area. It is very localized. So whatever the corrosion products are achieved or obtained, that is deposited in a very small confined area. That is why it is referred as a localized corrosion. Then pitting corrosion. Pitting corrosion is a corrosion which is confined to a small area as it takes the form of cavities on a surface. For example, in a very small area, due to the corrosion, it forms a cavity. So then it is referred as pitting corrosion. And crevice corrosion, it occurs at the location where easy access to the bulk environment is prevented, such as the joint between the two components. So we can see that this joint, so we can see that more corrosion happen, okay, because this area has a little access to the environment. So that is why you can call it as a crevice corrosion. Now we'll talk about some other different types of corrosion, particularly intergranular corrosion. It occurs when the preferential corrosion at or along the grain boundaries of a metal. We know that metal consists of the different grains. So between the grain or zone, grain boundary is there. So that is the point where the corrosion starts. It is very prone to corrosion. That is why we call it as intergranular corrosion. Then environmental cracking, brittle fracture of a material that occurs partially due to corrosive effect of an environment. So if any part of the metal is exposed to the corrosive nature of the environment, then the corrosion starts at that place. So that is called environmental cracking. And erosion corrosion, a corrosion reaction accelerated by the reactive movement of a corrosive fluid and metal surface. Sometimes we see in the sea there is a rod is immersed, so it will go up and down. So because of the corrosive environment or in contact with the saline water, so at the joints it leads to the erosion corrosion. So that is the erosion corrosion. Another is fretting corrosion. Fretting corrosion, damage at the interface of two contacting surfaces under load. So this damage is accelerated by the movement at the interface. So when this is moved one by another, so at the intersection or at the joints or at the surface, there is a corrosion. So that is called as fretting corrosion. De-alloying means that more than one metals are there in the alloy. So one of the metal will undergo the preferential corrosion. Okay. That means one metal will undergo corrosion faster rate compared to the another metal. So that metal zones will be corroded first. So the selective corrosion of one or more components of a solid solution alloy. For example, the dezinkification. So there is the alloy comprises of zinc and copper. Okay, so first zinc will corrode. So wherever the zinc will be there will be patches. Patches will be formed. That means the zinc will corrode. So that is called as a dezinkification. So one of the metal of the alloy will undergo the preferential corrosion, and therefore it is referred as a de-alloying. Now we are going to talk about the two types of corrosion. Mainly one is dry corrosion and another is wet corrosion. The name itself suggests that dry corrosion means that in the absence of moisture. So when any metal or alloy is exposed to the dry environment, so in the absence of moisture or water vapor, it leads to the corrosion, particularly the metal oxides. Then it will be referred as dry corrosion. And wet corrosion means that presence of moisture presence of water vapor is mandatory. That is why the name wet. So wet corrosion definitely involves the presence of water or moisture in the environment, in the immediate surroundings. So dry corrosion and wet corrosion. So now we'll see that what is the comparison of dry corrosion versus wet corrosion. So dry corrosion occurs in the absence of moisture, as I said before. It involves a direct attack of chemicals on the metal surface. Absence of moisture is a prerequisite criteria or condition. Then the process is very slow process. Corrosion products are produced at the site of corrosion. The process of corrosion is uniform in nature. So the corrosion product, whatever the metal oxides are formed, it is uniformly deposited over the surface of the metal. What is happening in the wet corrosion? Corrosion occurs in the presence of conducting medium. It involves formation of electrochemicals. Whenever the wet corrosion comes into the picture, definitely it involves the formation of electrochemical cell. And it is a rapid process. So whenever electrochemical cell, cathode and anode will be there, it will be decided which part will be anode, which part will be the cathode of the metal. Corrosion occurs at the anode and rust is deposited at cathode. Corrosion occurs at anode and rust, that means whatever the corrosion product, that is deposited at cathode. And it depends on the size of the anodic part of the metal. So these are the main salient features of dry versus wet corrosion. So dry corrosion occurs when the metals are exposed to gaseous environment. It occurs when there is no water or moisture to aid the corrosion and the metal oxidizes with the atmosphere alone. Oxygen is there or any other gas is there. So the metal reacts with these gases. The gas, it can be oxygen or any other gas. But there is no moisture in the immediate surroundings. The extent of corrosion and protective values depend on the following factors: chemical affinity between the environment and the metal, adhesion between the film and the metal surface, nature of the film formed, and the protective value of the film. So these are the factors which decides that the extent of corrosion: chemical affinity between the environment and the metal, adhesion between the film and metal surface, nature of the film, and protective value of the film. Now we'll see that what are the essential conditions for dry corrosion. The presence of a reactive gas. What type of gas is present? Whether oxygen is there or carbon dioxide there or any other gas is present near the surface of the metal. Absence of moisture or electrolyte. I told that whenever the moisture or water vapor is there, it forms electrochemical cell. So the dry corrosion does not involve the electrochemical cell formation. So that means absence of moisture is a prerequisite condition. Elevated temperature, chemical active metal surface, thermodynamic feasibility, and gas permeability through the oxide layer. So whatever the oxide layer forms, how efficiently it acts on the surface. So if it is uniformly deposited and thicker enough, then it will prevent the further corrosion. We call it as a passivation. So it depends on the nature of oxide layer. But if the oxide layer, whichever forms on the metal surface, can be easily broken, then what will happen? Gas can enter through these pores and can reach the metal surface and again initiate the dry corrosion. So the oxide film, the oxide layer which is deposited on the metal surface is very crucial. The thickness of the film, it dictates how much passivation it will do. If it is enough passivation, then it will further prevent the corrosion. But if it is too thin, then it will break. If it is too thick, it will come out from the surface. In both ways, it will not lead to the good passivation. So the dry corrosion, what are the examples of dry corrosion? This type of corrosion is mainly caused due to the direct reaction of metal surface with atmospheric gases like oxygen, CO2, H2S, SO2, nitrogen, chlorine, etc. What are the examples of dry corrosion? Scaling of boiler tubes at high temperature, oxidation of aluminium forming protective layer, alumina turbine blade corrosion in jet engines, sulfur corrosion in refineries and chemical factories, etc. Now, if we see that the mechanism of dry corrosion, how it happens in absence of moisture, how it leads to the oxide formation. So the corrosion by oxygen we'll talk about, or oxidation corrosion. Oxidation corrosion is brought about by the direct attack of oxygen at low or high temperature on metal surface in the absence of moisture. Several alkali metals like lithium, sodium, or alkaline earth metals like magnesium, calcium, tin, etc. rapidly oxidize at low temperature. At high temperature, almost all metals except silver, gold, and platinum are oxidized. So the reaction of oxidation corrosion are as follows. First, what will happen? Metal will give up the electron to form the metal ion. So in this case, metal will give up the 2 electrons to make it M2 plus. So it forms a metal ion. So this is the oxidation. Oxidation takes place at the surface of the metal, forming the metal ion M2 plus. It can be different metal ion depending upon the nature of the metal. Then these electrons, where it will go? For oxygen, it will undergo the reduction. Oxygen is accepting these electrons generated by metal to form the oxide. The oxygen is converted to oxide ion due to the transfer of electrons from the metal. So basically we can see here oxygen, it will accept the electron, the necessary number of electrons to form an oxide. And the third step is that the combination of metal ion and the oxide to form a metal oxide, which is nothing but corrosion product. So the overall reaction is of oxide ion react with the metal ions to form a metal oxide. So you can see here that metal ion combines with the oxide to form a metal oxide, which is corrosion product. So the nature of the oxide plays a very important role in the oxidation corrosion reaction. So these are the stepwise mechanism of the dry corrosion. So if we consider M is an iron, so iron, first it will form the Fe2 plus 2 electron. Oxygen will accept the electron to form a oxide, and then Fe2 plus will merge with the oxide to form a iron oxide. So iron oxide is a corrosion product.